Okay, this section is on the quadratic formula and the discriminant. Okay, and the quadratic formula always assumes that you're starting with an equation in this form, where a, b, and c are numbers. Okay, so a is always going to be the coefficient of the x squared term, b is going to be the coefficient of the x term, and c is going to be the constant. Okay, the thing I think that I'm going to do real quick is show you how it's derived, because it's pretty cool. And I'm of the feeling right now on the quiz, if you can actually show me how to derive it the way I'm doing it now, I might give you an extra credit point. Okay, so we learned yesterday how to complete the square, right? The quadratic formula was actually derived by completing the square on this equation. So if we go through the exact same process of completing the square that we learned yesterday, ultimately we should derive the quadratic formula. Okay? And so what the formula gives you is, if you were to complete the square on whatever your equation is, at the end of that, if you would just plug those same numbers into the formula, you would get the same answer. Okay? So what's our first step when we complete the square? Yep, so move the constant over. Okay, what's the next step?
Divide b by 2.
Not quite. What is that? That step works when x squared has what as the leading coefficient? 1. Is 1 the coefficient here? No, it's a. We're going to assume it's not. It's just a. Okay? So what do we do then to get 1? Like if that number was 3, what would we do? Divide everything by 3. So that number is a. We're going to divide everything by a. Okay? So ax squared divided by a is just x squared. Bx divided by a is b over a x. With me still?
Yeah.
And then negative c divided by a is negative c over a. Now we take that middle term, that x coefficient, divide it by 2, and square it. Right? That's what we learned yesterday. Well, when we divide something by 2, we're essentially multiplying the denominator by 2. Right? So what we're going to add here is b over 2a squared. Make sense? I just divided b over a by 2, and then I squared that term. And whenever I add to the left, I have to add to the right. Did I lose anybody yet? A lot of letters, but it's the same exact process that we went through yesterday. We're just pretending they're numbers. Okay? It's going to look really complicated, but it's just what we've been doing. All right, so now we're going to factor this. The whole reason we did this was to factor it. Right? Whatever you divided this, when you divided this by 2 and squared it, you got your constant. But when you divide it by 2, that's what this term is. Because this term squared is your constant. Right? Well, if we had 7 as our middle term, no, let's do 14. Make it easier. We would divide this by 2, and then square it, and that would be our constant that we'd add, which is 49. But to figure out the number that goes here, it's just 7, whatever number you did before you squared it. So that's what I did. It's just this number before I squared it that goes here. Because if I were to expand it, my last term would be b over 2a squared. With me? Okay? And on the right then, what I'm going to do is just some algebra, some fractions. Okay? I have negative c over a plus, and I'm going to go ahead and expand this. When I square the numerator, I get b squared. When I square the denominator, I get 4a squared. Ever understand that? Now, if I want to combine these two fractions, I have to get a common denominator. Well, 4a squared is my common denominator. What do I do to the left fraction to get 4a squared? What do I have to multiply it by? 4a. Because I already have 1a. If I multiply it by 4a, I get 4a squared. Right? So I've got to multiply top and bottom by 4a. And this becomes negative 4ac over 4a squared plus b squared over 4a squared. Right? When I multiply a times 4a, I get 4a squared. And when I multiply negative c times 4a, I just get negative 4ac. With me? And now what I'm going to do is just switch these so I have a positive first. So this is b squared minus 4ac all over 4a squared. Just switching those because the commutative property tells me I can. Order doesn't matter. Everybody see how I got this?
Yeah.
Okay, so now I'm going to just replace this with that. So the next step now is to do what? To solve for x. If there were numbers there, what would you do? Take the square root of both sides. Yeah. So if I take the square root of this, I get x plus b over 2a. If I take the square root of this, I get that. I can't really, if I take the square root of the whole thing, it's the same as taking the square root of the numerator and the square root of the denominator, right? The square root of the numerator can't be simplified. But the denominator, what's the square root of 4a squared? What's the square root of 4a squared? Well, it's the square root of 4 times the square root of a squared. The square root of 4 is 2. The square root of a squared is a. Okay, so in the denominator, I have 2a without a square root. And that's equal to x plus b over 2a. So the last step is just to subtract b over 2a from both sides. These have like denominators. So then it just becomes and I just derived the quadratic formula, which is up here on the wall if you need it. Okay, so you can complete the square or just plug a, b, and c into this formula, and in the end you'll get the same answer. Okay, so let's just do one, and I'm going to do it 3 ways. First way, factor. Well, to factor this, bottom is up. Right? So my answers are -5, +6. Second way, complete the square. Add 15. Divide by 2. Right? Now, take half of this, which is 1/4, and square it. Because half of 1/2 is 1/4, I just multiply the denominator by 2, and then I square it. And then factor that. And then I have to add 1/16 over here. Did I lose anybody?
How did you get the
I take half of 1/2, which is 1/4, and I square it.
Oh,
Yeah. Well, I had to divide everything by 2. And then I had to take half of the middle term and square it. And I had to add that to the other side. So this becomes, what's 15 times 8? 120. Right? 120 over 16 plus 1 over 16 is 121 over 16. Take the square root of both sides, plus or minus. I have x minus 1/4 equals plus or minus 11/4. Square root of 121 is 11, square root of 16 is 4. Add 1/4. Or 1/4 minus 11/4. Do this right? Oh, you know what I didn't do here? What you guys forget to do? So x is equal to -5/2 or -3. So 1/4 plus 11/4 should say 3 is 3. 1/4 minus 11/4 is 10/4, negative, and then simplified is -5/2. Same answer. Right? 1/4 plus 11/4 is 12/4, which is 3. 1/4 minus 11/4 is -10/4, which is -5/2. Where did I lose you? Anywhere? Yeah?
yeah.
Where?
Oh, no, good.
Okay. All right. The last way is the quadratic formula. What is it? Minus 15. Okay. A is 2. B is -1. C is -15. It'll help you if you just identify A, B, and C at the top of your problem. Okay, now I'm just going to plug it into the formula. Formula is -b plus or minus the square root of b squared is 4ac all over 2a. I promise you it will benefit you to memorize this. If you have this memorized for the ACT and you get a quadratic, you could spend your time trying to factor it. You could try and complete the square or just plug it in the formula. Okay, so b is -1, so negative b is +1. B squared is 1 minus 4 times a times c. 2 times a is 4. So I have 1 plus or minus the square root of negative 15 times 2 is negative 30, times 4 is negative 121, 120, negative 120. If I have 1 minus a negative 120, it's positive 121. Right? This whole thing's negative 120. And I have 1 minus negative 120, which is 1 plus 120. Right here is where you're going to mess up, is forgetting to multiply it by the negative. Okay, so be really careful on your math when you do the inside of the radical. That's the easiest place to miss this. Okay, all over 4. So this is 1 plus or minus 11 all over 4. So what's 1 plus 11? 12. What's 1 minus 11? Negative 10. Simplified. Got the same answer, 3 different strategies when I do all 3 correctly. Okay. One final thing in this section that you need to know, something called the discriminant. The discriminant is the radicand, what's under the radical. It is not including the radical. It's strictly what's under the radical, which is b squared minus 4ac. That's called the discriminant. And it's really powerful because it can tell you right away what kind of answers you can expect when you're done. Okay? If the discriminant is equal to 0, there will only be one answer. Which means if you were to factor it, it might give you something like this. That's one answer when I set it equal to 0, right? Negative 3. It's negative 3 twice, but it's the same number. So if I were going to use the, because this is actually that expanded. If I were given this as my factored problem, and you didn't want to factor it, and you didn't want to complete the square, you wanted to use the quadratic formula, the discriminant, b squared minus 4ac, that expression under the radical would be equal to 0, because we only have one solution. Okay? If b squared minus 4ac is positive and not 0, you'll have 2 real answers. Okay? So look at our solution. Was b squared minus 4ac, which in this case was 121, is it positive? Yes. So I know I'm going to have 2 real solutions, which I did. Okay, if this number is negative, there's going to be 2 imaginary. Why? Because we have a negative under the radical. Okay, so you're going to have questions, and you'll have a question on a quiz and a test to tell me what the discriminant is and what it means. So in this case, the discriminant is 121, not the square root of 121, just 121. And because it's positive, it means there's 2 real solutions. Okay? Quadratic formula. We will have a quiz tomorrow over both completing the square and using the quadratic formula and understanding the discriminant. So make sure, if you haven't finished yesterday's homework, you get that done quickly so you have a chance to work on the homework problems for this section. Okay.